All right, welcome back to Mr. P Helps with Calculus. This is Unit 2, day number 7. As we get into the basic rules of derivatives, we're going to be learning about power rule, and we're going to, something you're going to use 1,000 times, and constant rule. All right, so starting off with a quick little warm-up. I know I covered this in a previous video, but this tends to be one of those topics that students just struggle with the most, using limit definition of a derivative to find essentially the slope at a given value. All right, so now we're given 5x plus 8. Now, this is really f of x plus h minus f of x over h, which is the most basic limit definition of a derivative. So essentially what you see here in parentheses is this function, but replacing x with x plus h. It's literally the same thing. And then you're taking away f of x, which is the function. This is f of x. And then you're putting it over h. Now, you could not plug in 0. That will not make any sense because you're going to get indeterminate solution. You're going to get 0 over 0. So what you have to do is simplify. Use your distributive property, subtract these two, and that's going to leave you with this. And then you can cross out the 8's, cross out the 5x's, so you're left with just 5h over h. Then you're eliminating the 0 over 0 when you get rid of the h on top and bottom, and then you're just left with, well, plug 0 in for h, but there are no h's, so the answer is just 5. Now, if you think about that for a second, if we take a linear function is going to have a number, a constant, and that's pretty much always going to happen, and you're going to see why that always happens here in just a second. Well, we're going to start off with just a constant first. Not, well, a linear function technically, but really it's a special one where it's just horizontal. So this happens to be a horizontal line at 3, and we're asking ourselves, well, what would the derivative of this be at any given value of x? Well, if you look at a constant, any constant's going to go straight across like this, meaning the slope is always going to be 0. So the derivative of any constant is always going to look like this, and it's always going to have a slope of 0, which is why the derivative of any number, whether it's be rational or irrational, does not matter. It will always be 0. So pi, 3.14, which would be slightly above it, is still just a constant. So the derivative of pi is still 0. Now we're going to take a look at the most commonly used thing in this entire class, is using the power rule of derivatives. Now, power rule of derivatives, I know this looks like very complicated, but it really is actually quite simple. Meaning, if you take the derivative, d dx, the derivative with respect to x of any sort of base, in this case we're just saying it's x, it could be any number, to any power n, it could be anything, all you got to do is take that power, put it down as the coefficient, so that n is going to be in front of the x, whatever the base was. The base stays the same, and you drop that power, whatever number that was there as the exponent, is going to drop by 1. That is essentially it. Take whatever number's in front, multiply it by whatever coefficient might already be there, and then drop that number by 1, and it will always work. Now, if I go back a second to the warm-up, so if this is 1, 1 times 5 is 5. So if we multiply this times this, we get 5. And if we drop 1 minus 0, we get 5 to the first, which is just 5, our answer. Now, let's do the same thing for this term. This is a constant. This is really 8 to the first power. 1 gets multiplied by the front, and then it gets dropped, so it's 1 times 8 to the 0th, right? Because this gets dropped by 1. And 8 to the 0th is really just 1. 1 times 1 is 1. 5 times 1 is still 5. So yeah, that works for that previous question. So once again, this is 1. 1 gets brought into front. Drop it by 1. You get just 1. 2 gets put in front. Drop that by 1. You get 2x to the first power. And that's it. 3 comes in front as the coefficient. Drop that 3 by 1 into a 2. Now, I won't always do, and matter of fact, after like a day or two of this, I don't ever do this step. I just go straight from this question straight to this answer. Once you do this, and you're going to be doing this thousands of times over the course of the entire year, you're going to get very quick with it, and you're going to go straight from here to here. Bring the 4 down to the front, drop that power by 1, and then you get 3. So it's 4x to the third. which means, by the way, if the derivative of y with respect to x is this, means that if you put any value of x in for here and you solve it, that would be the slope at that value of x. That's essentially what a derivative is. It's a function in this case that tells you what the slope would be at any given place on the entire function. That's what makes it special. All right, now what if it's a negative up here? What if it's x to the negative first? Well, you can't do it like this. You need to change 1 over x to x to the negative first, and then do the exact same steps. Move this down to the front as the coefficient, and then drop it by 1. And that happens to be the same thing as this. Now, either one of these answers, they're going to be the exact same thing. And all these questions are done just the same. What if it's a radical? Well, that's really just 1/2 power. I would always change all radicals into rational functions. So x to the 1/2 power is the same thing. Bring that 1/2 down in front and drop that 1/2 by 1. So always subtract by 1, which ends up makes it a negative, which means to make it a positive, you would just move it to the bottom. So it's 1 over 2 root x. All right, so another example we have here is the constant multiple rule. Now, I'm going to be honest, I don't always do this rule, but it is something that is helpful just to have as your bag of tricks, because you're going to get the same answer even if you don't do this. But if you have a constant being multiplied by a function, you can literally just separate. You can literally just take that constant, move it out in front, and just take the derivative of the function itself. Meaning, if I take this 5 out of the equation, so I'm going to take that 5 and just take the derivative of x squared. Well, the derivative of x squared would be 2x. 5 times 2x is 10x. Now, why does that not really matter? Now, I'll show you. If you multiply 2 times 5, you would get 10 as is. And then drop this by 1, you get 10x. So yeah, you're going to get the same answer whether or not you move that constant multiple out or not. But it is definitely helpful to know this rule just for future problems where you might need to use this rule even when you can't do it. Break -3, multiply it by 2, you get -6. Drop this by 1, you get -4. Remember, change this radical to rational. 1/2 of 6 is 3. Drop this by 1, you get -1/2, which would be the same thing as 3 over root x. There it is. I didn't see it over myself. All right, sum and difference rule. So another pretty basic rule, and you kind of already saw me apply this on that previous warm-up when I went back. Basically what it says is anytime you have a plus or a minus in between terms, so there's really 1, 2, 3, 4 different terms here, basically you just find the derivative of all of them separate. So do d dx of this, do d dx of this, d dx of this, and d dx of this, and these will be your answers. So that's all really sum and difference rule states, is that you can just separate them and find the derivative of each piece separately. So change this to rational. -2 times 5 is -10, and then drop this by 1. Well, it makes it -3, so you move it to the bottom. -1 times 4 is -4. That's their negative right there. You could write plus and negative there, but I don't do that. And then drop this by 1, you get -2. Move it to the bottom to make it positive. And remember, the -1, the derivative of any constant, will always be 0. There's no reason to put that, so I'd kind of drop that off of my answer. All right, what are the values of x when the tangent line of f of x is horizontal? Well, that would be anytime the slope is 0. So this point right here happens to have a slope of 0. So f prime of x equals 6x plus 5. That's the linear piece that's right here. What are the x values where the tangent line to f of x equals 6x plus 5? All right, so essentially what we have is a visualization. We have this blue is the derivative of this function, which is this. So one way we could verify this is use our power rule to find the derivative of this. And the derivative of this is 6x plus 5, which I've written here. Set that equal to 0. We're trying to find when the derivative is 0. Well, it will be 0 right here, but the problem is that's a decimal. That's like -1 point something. So how do I find that 1 point something? Well, that's why I'm doing what I'm doing here. I'm finding the derivative of the original function, since this graph didn't really help me because it was not a whole number. And then I set that equal to 0. I'm essentially trying to find when does this graph have that slope of 0. So I set that derivative equal to 0, and I solve, and there I get negative 5, 6. Which means, if that's really the answer, then these graphs aren't accurate. I need to move that, slide that over just a little bit to the right. Because that's not where negative 5, 6 happens to be. Let's see. Checking the math, divide by 6. Yes. Obviously, that's not an accurate graph. All right, take a look at the next one. Same steps. Find the derivative of the original function, which is cubic, so that's clearly the red one. Now, what you're going to probably notice is that if the original function is cubic, you know the derivative is going to be quadratic. It's always going to be one less. Because remember, it's always x to the n becomes n times x to the n minus 1. You're always dropping the power by 1 when you find a derivative. So d dx of x to the n will equal this. That's your power rule. So yeah, if it's quadratic, if it's cubic, it's going to become quadratic when you find the derivative. 3 comes down in front, 3x to the second. This becomes 4x, and this is a constant. So the derivative of that is just 0. All right, so essentially we're going to take this, we're going to set it equal to 0. We're going to try to find when are these two times, which happen to be the two times when the slope happens to be equal to 0. But we're going to try to find when are those two times. So set that derivative equal to 0. Factor out the x. Let's see, x equals 0 would be this point. And 3x, let's see, minus 4 divided by 3, negative 4 thirds. Negative 4 thirds. Yep. Okay, so it looks like it's going by halves. Now, let me see. Was that the issue on the last one, too? Oh, it was. Oh, I didn't realize. Okay, so that's not inaccurate. Sorry. This is going by halves, not one whole. So, yeah, that is about negative 5, 6. All right, so those are two perfect examples. Thanks again for watching. I'll see you in the next video.